This is the UR robot that we were working with. We're going to attach the gripper to it now. Here's the patty that we will be picking up. This is the iterations of the gripper. This is the final design. This is the 3D printing process of the gripper and the patty. We had to go through multiple iterations of the gripper to get it just to fit right, just with the patty, increasing the slope for it to slide in and increasing the radius and the depth of the gripper so it wouldn't get stuck. This is the grill that we will be cooking on, quote in quotes grill. We had to set up a network with the UR, a private LAN with the UR robot and the PC that we are working with. So this part of the video is showing the application RViz representing the UR robot in ROS. You can see here that we're picking positions for the robot to move to, and then we're doing plan and execute, and plan and it's moving to those positions. And you can see that we are able to choose both translation and rotation pieces and rotational movements of the UR robot. So you can see they're moving center, left to right, and up and down. But we can also move purely translationally. And this is obviously way different from the template that normally one uses with the UR robot. This is, I believe, way more user-friendly. And we did use this for debugging and moving the UR robot while we are still developing our application and our motions when we were flipping burgers. You can see that here, but this is kind of our application planning with the robot. You can see the plans. The sort of translucent movement of the robot is the plan of the robot before it moves to those new positions. And this is just a route of it flipping the burgers back and forth. You can't quite tell yet. And this is our simulation of the robot in Gazebo. You see we have a little burger joint behind the robot, and it's outside cooking burgers. So this is just a nice little aesthetic piece of what the real potential of using the robot in Gazebo, like representing the robot in Gazebo. So here's a video of our robot actually flipping the burgers. So really the power of this simulation is wants to be represented. For example, while we were doing this project, we were competing with other groups for the robot. They were working on other projects with the UR robot, and we were able to do a lot of this in the simulation without even touching the real hardware. We were getting the motions down and making sure that we were interfacing with the robot correctly, and we did a lot of the hard stuff in simulation, and only at the last moment when we need to did we interface with the hardware. So we were able to have multiple teams messing with the UR robot while there only being one UR robot. And obviously in Gazebo you can have much complicated more scenes and objects that can actually be manipulated without that scenes being actually realized in real life yet. So in this example we're flipping burgers, and as you can see the sim at the bottom right, the UR gripper, the robot IQ gripper wasn't able to be represented, and we weren't able to actually manipulate real objects in Gazebo, but that would be the next iteration of this project, actually manipulating real scenes within Gazebo. Here it was just sort of a demonstration of the power of Gazebo, and we'd like to iterate that and, like I said, manipulate real objects. Another thing we'd like to add is vision control, so the robot is really just returning back to the positions that were programmed within the application through the paths that were also designed in the application, through the application of RViz and such. And we'd like to implement vision control so that it's not so open loop control of picking up the burgers and placing them back down. And you can implement vision both in the sim and in the hardware. And that's essentially our project in a nutshell, just a nice flipping of burgers and then the representation of that in the sim. So thank you for your time and thank you for watching.